early man was a hunter-gatherer, dependent upon climatic conditions and the availability of water. His hunting skills determined his survival. If there were animals to kill, or he could find wild fruits, nuts, and berries, he ate. If not, he died. In prolonged adverse conditions, the vegetation died. Animals died, and so did he. As knowledge of animal husbandry and agriculture increased, it became increasingly possible to control the food supply. A beast could be slaughtered from the herd or flock, which also provided a steady supply of milk. But the problem remained that crops mature over a limited period of the year, and food deteriorates and becomes very scarce during the winter. It was the necessity to store, preserve, and transport that gave rise to the development of storage methods and to containers that would help reduce the seasonal fluctuations in availability. The first recorded food container is as old as creation. It maintains its contents in excellent condition. Access to contents is easy, though it is not reclosable. It's still used extensively, and you may be familiar with it. Like most packaging, it comes in various sizes. The first man-made containers were adapted from naturally occurring animal and vegetable sources. Skins were used for water and wine, and vegetable gourds, coconut shells, and reed and wicker baskets served as containers for a wide variety of products. Next came the development of containers from naturally occurring materials. Pottery vessels from clay, cases and casks from wood, and leather items from hides. The Egyptians were expert workers in wood and stone, but where the previous examples were directed to the preservation of the living, they were very much preoccupied with preservation of the dead. The principles are very much the same, and our knowledge of their civilization is mainly derived from mummified objects. The body was embalmed in cloth wrappings and placed in the inner carved and decorated wooden mummy case, which was in turn enclosed in an outer case also of wood. A high standard of workmanship was achieved, though today there could be suggestions of over-packaging and criticism from consumer organizations. This treatment was only for the rich and famous. Lower down the social scale, you only qualified for a reed coffin, and even to get this required a little arm and leg twisting. Later came the wooden cask or barrel made from shaped and curved staves held together by hoops. The basic construction has remained unchanged for centuries. The third phase required the development of technologies for the conversion of naturally occurring raw materials into new materials. The smelting of metals from ores. The production of glass from sand. The production of paper. Glass was first made sometime before the year 3000 BC, but the first known hollow glass containers date from around 1500 BC. A major technical breakthrough came in the 1st century AD with the invention of glass blowing, which opened the way for commercial development and the spread of glassware through Europe by the Romans. The Industrial Revolution led to the mass movement of population to large urban areas. Not only did the great increase in trade develop the factory system, but also the specialist retail grocer. The grocer received everything in bulk: butter and cheese in casks, vinegar and oil in barrels, sugar, flour, rice, dried peas, beans in sacks, and tea in chests. Everything was weighed out on the premises as required by the customer. There was no extra charge for the rat and mice droppings, and a good cat was essential. From the early Egyptian bottle to the unhygienic Victorian shop took about 3,500 years. In less than 100 years, this has evolved into the modern hygienic supermarket. How? The superficial answer is the development of packaging and packaging materials, but that would ignore the complex interrelated factors which gave rise to and accelerated this development. That fresh food deteriorates was well known, but the causes were not understood. Food preservation by drying, salting, and pickling was a long-established practice, but the range was limited and the results unappetizing. The means by which food contamination could be prevented became obvious when Louis Pasteur discovered the crucial role of microorganisms: kill the germs and prevent contamination. Pasteurization and other heat treatments were developed, and for the first time there was a means of keeping a very wide range of perishable foods in excellent condition over long periods and in containers developed for the purpose. Apart from microorganisms, rodents, maggots, and weevils, the principal agents of spoilage are moisture and oxygen, which may produce physical and chemical changes and encourage microbiological growth. It's the function of a package to provide a barrier against these adverse factors and at the same time preserve the ingredients. Needless to say, the package must not leak or react with its contents. Glass satisfied all these conditions, but there was a problem in effecting an airtight and vapor-type closure. A range of bottle lids, closure is the technical term, were developed over the years, and in 1896 the Crown Cork saw the launch of Coca-Cola onto the world stage. Before the First World War and well into the 1920s, milk was sold from horse-drawn carts. It was transferred into jugs at the doorstep using a measure wielded by the same hand that led and tended the horse. The milk did not keep in warm weather, it was not pasteurized, and was an excellent culture for a number of nasty diseases. With the introduction of a reclosable milk bottle and pasteurization in the 1920s, doorstep delivery of milk became almost universal. The development of closures continued after World War II, making possible the effective vacuum sealing of a whole range of products, including baby food, instant coffee, preserves, fruit, and pickles. In 1810, the metal food can was invented and, like the glass jar, was used to supply troops in the Napoleonic Wars. The present three-piece tin plate can was developed in the 1900s and, like glass containers, brought about the development of automatic packaging machinery. Apart from metal and glass, special equipment was designed to convert paper and carton board for the use in packaging basic grocery items like butter, tea, flour, and sugar. For such relatively stable goods, cartons and bags give adequate protection against contamination. It was shortly after the Second World War that what can be fairly described as a revolution took place: the birth of the petrochemicals industry, the plastics revolution. Derived from petrol by new and complex technology, whole families of completely new materials have been developed. They differ in chemical and physical characteristics, but all share one important property. They are thermoplastic, that is, they can be melted by heat and shaped into a whole range of containers, both rigid and flexible. They are hygienic, reclosable, and can be cheaply and attractively decorated. Plastics can be extruded too into film to form very cheap, effective packaging for a whole range of products from frozen foods to biscuits and potato crisps. So the 19th century grocer's shop, with its limited range of bulk-delivered goods, has evolved into the 20th century supermarket, stocked almost entirely with pre-packaged units and with produce from all over the world. Packaging allows products to be displayed to their best advantage with eye-catching graphics on bright, colourful containers. But the role of packaging extends much further than tempting the customer to buy. It's expected to protect the product, provide hygienic handling, and prolong its shelf life. Packaging protects and preserves, contains and informs. It's designed to fulfill all these essential features, and design includes choosing the right material as well as the shape, the color, the closure, transport considerations, and final disposal. Although traditional drawing board and model-making methods are still used. The use of computers has enhanced the ability of packaging designers to create new container shapes and styles in minutes rather than days. The packaging designer works closely with the marketing and production staff, advising on materials, structural and graphic design, and the interface between the materials and the packaging machinery. To perform the task of informing, many containers bear a label. Labels are used when it would not be possible to achieve high quality by printing directly onto the container. Labels are also used where a standard container, like a metal can, is used for several different products, or when the information is not determined at the time of filling, like the weight of a piece of cheese. The words on the labels must be correct, and what they say must be true. There is detailed legislation governing the labeling of products, especially medicines. Goods can also be identified by scanning devices which read barcodes. Manufacturers have a reference number and a block of numbers to allocate to each and every product. Barcodes and computerized point-of-sale equipment speed up the checkout service, itemize till receipts, reducing errors to almost nil. The system also provides vital stock control and marketing information. The store manager not only knows which products are selling, he also knows which to restock. Glass, metal, and most plastic containers with appropriate closures are designed to contain their contents without additional aid. Paper, carton, and carton board packages usually require the application of one or more adhesives to keep the pack together. Adhesive glue is itself a complex structure of chemical compounds and, like the inks used in printing, has to be carefully selected and used. The machine speed, temperature, and humidity all have to be just right if the adhesive is to do its job. Holograms, at one time a gimmick in cereal packets, now play a vital role in combating counterfeiting and tampering. Many labels incorporate holograms and can be made to change if a pack is opened or interfered with. Closures not only help to contain the product, they can also supply evidence of tampering. The lids of these baby food containers become depressed once the seal is broken. The printing processes used for labels and for direct printing onto the container are often incorporated into the packaging machinery. Color obviously plays an important role in making a pack attractive, and inks are carefully chosen, not just for color, but with reference to their chemical structure in relation to the pack and its contents. Packaging is more than just packets, bottles, cans, and jars. Collated packs become pallet loads, and pallet loads lorry loads, also designed to protect, contain, and inform. Convenience, innovative design, and a careful use of several materials resulted in the familiar flat pack. These transit packs protect and contain the ready-to-assemble contents and drastically reduce the space needed to store and transport the finished article. Consumer goods, food and beverages, as individual items, are packaged for the convenience of the end user, but the design of the packaging enables large quantities to be both easily displayed and stacked and transported in bulk. Larger items of machinery are also packaged with the same basic principle being applied to protect, contain, and inform. Secondary or ancillary packaging is designed to ensure that goods arrive intact, fit for use, and in an easily accessible form. Non-food packaging, electronic equipment, machinery, and dangerous cargoes like chemicals or explosives require the same painstaking design processes to ensure that their valuable or dangerous contents arrive intact and can be safely stored. A package may have to withstand a journey by land, sea, and air, and in a variety of vehicles, and be subjected to a wide range of temperatures and other hazards. The packaging technologist is responsible for ensuring that the package can do its job under all circumstances. In protecting food products from contamination, packaging plays a vital role in the nation's health. In some third world countries, because of poor packaging and storage, 30 to 35% of all crops grown rot in the fields. In the developed world, wastage is less than 3%. Consumer goods, from CDs to fashion clothing, only begin their useful life when they are purchased. Packaging, however, has nearly completed its useful life when it reaches the consumer. It is usually then that it's noticed, it's got to be got rid of, and it is no longer necessary. Packaging has to be designed to take account of its effect on the environment at all stages of use. To minimize environmental impact, the industry strives to reduce waste at source, at the production stage, by pre-cycling, that is, reusing production waste at an early stage in the form of raw material or for fuel energy. Packaging, like all products, uses raw materials and energy, both costly to the manufacturer, and this is an economic incentive to keep the use of resources to a minimum. There is no incentive to overpackage. Environmental concern is not new to the packaging industry. Over the years, packages, which looked the same, have in fact been reduced in weight whilst containing the same volume, or by the use of new materials. Reducing packaging to a minimum has to be carefully considered because flimsy individual consumer packs may require stronger, more expensive transit packs to contain and transport them. The challenge to the industry is to reduce material and energy use without compromising the protection of the product. Packaging has evolved to match our modern lifestyle. Before the Second World War, people shopped daily, and packaging materials were grease-proof paper bags and string. Staff served the customer and explained the product. Now we shop in bulk, buy almost everything pre-packaged, and serve ourselves. The pack tells you all you need to know about the product. Transport is an expensive cost in financial and energy terms. Properly designed packaging can make it cheaper and save money and energy. Despite proper and economic design, used packaging has to be disposed of. The options are reduction of waste at source and reuse. Milk bottles are a good example. Recycling, reusing the basic materials again, either for more packaging or in other forms. Recycling includes composting, where sorted household waste is cleared of all metal, crushed, and then left to compost into usable garden compost. Incineration, burning to recover heat energy. And landfill, not just dumping in a hole in the ground, but carefully planned management of waste materials which will not leak into the water systems or give off uncontrolled gases. Litter is a nuisance. It affects everyone's environment. Control of it is in your hands. Packaging has a job to do and does it well. Litter is caused by people being careless. Packaging protects you, and it helps protect the environment. Packaging protects, preserves, contains, and informs. Imagine what life would be like without it. Open This End is produced by the Institute of Packaging, the UK's only professional body for packaging technologists. It provides education and training and qualifications in packaging technology, organizes overseas trade exhibitions, publishes and sells books, runs design competitions for both industry and design students.